Hello everyone, and welcome back to All About Python. In today's lesson we're diving into one of the most fundamental and surprisingly fun parts of coding in Python. Strings. Whether you're dreaming of building a website, designing a game, or just automating some boring tasks, you'll be working with text. Let's look into what exactly a string is. So, what exactly is a string? A string is just a sequence of characters, letters, numbers, symbols, or even spaces, all wrapped up in quotes. You can use single quotes or double quotes, Python doesn't mind. Both work the same way, so you can choose whichever feels more natural. But here's where it gets clever. If your string contains quotes inside it, Python lets you mix and match. Let's go over to our coding environment and see this in action. Let's start with creating a new Python file called strings.py. Using single quotes type I am a string. Now on another line using double quotes, type I am also a string. Now copy me as we mix and match. Let's do a line wrapped in single quotes, with the text, "She said Python is awesome." Don't forget to encase Python is awesome in double quotes. Let's do one more, this time use double quotes to encase the text. Write the text, "He also said," now add a comma, then type Python's awesome. Be sure to add a single quote between Python and the S. Well done, you have just written your first 4 lines of strings in Python. Alright, follow along as we take things one step further. We've got 4 lines of text, and now we're going to add a print statement to each one. We do this because print is how we tell Python to show us something. Right there, in the console. It's like giving Python a little nudge and saying, "Hey Python, show me this line." Whenever you use print, you're asking Python to take whatever's inside the parentheses and display it on the screen. It's one of the simplest, yet most powerful tools you use, especially when you're just starting out. So go ahead, add the print function to these strings. Now, when we run the code, Python will display all 4 lines, one after the other, right in the console. Each print statement tells Python to take the text inside the parentheses and show it to us on the screen. So as the program executes, it moves line by line, printing each message in the exact order we wrote them. This is a great way to see how Python reads and processes instructions from top to bottom. It's also a simple but powerful way to check that your code is working as expected. So go ahead, run it, and watch your messages appear like magic, one after the other. When you're working with text in Python, whether it's names, titles, or user input, you'll often want to control how that text appears. Should it be all lowercase, all caps, or title case? Python makes this easy with a few built-in string methods. Let's take a look at a simple example. Alright folks, welcome back. We're inside VS Code now, and I've got a simple example on screen that shows how to change the case of text using Python's built-in string methods. Let's walk through it together. Take a moment to pause the video here if you need to, and copy this code into your own editor. Once you've got it typed out, hit run or Ctrl+Enter, and let's see what happens. Now, here's what each line is doing. First, we create a variable called name and assign it the string John Doe. It's all lowercase for now. Then we use title. This method capitalizes the first letter of each word. Next, the upper method converts every letter to uppercase. And finally, lower ensures everything is lowercase, just like the original, but this would be useful if the input had mixed casing. These methods are super handy when you want to format names, clean up user input, or make your output look polished. So go ahead, run the code, watch the results in the terminal, and get comfortable with how Python handles text. Once you've seen it in action, come back and we'll look at variables with strings. Alright. Let's talk about combining variables with strings in Python, using something called fstrings. Fstrings are a super handy way to create dynamic messages that include values stored in variables. Let's jump back to the code editor and take a deeper look. As you can see, we have added some more code to the editor. If you need to, pause the video and copy this code into your own editor. So, what's happening here? We've got 2 variables, first name and last name. We combine them into a new variable called full name using an fstring. The F before the quotes tells Python, hey, look inside this string for variables in curly braces. Then, when we run the code, Python replaces full name with the actual value, which is in this case John Doe. And also applies the title method to capitalize each word. We then go one step further and store the contents of the variable full name in a new variable called message. This shows how we can keep our code clean and also allows us to reuse the message later if we need to. F-strings are simple, powerful, and perfect for creating personalized output, especially when working with user input or displaying information clearly. Try it out, and see how easy it is to make your Python code feel more interactive. We're going to now look at another way to combine strings in Python, using something called string concatenation. We have talked about F-strings, which are super clean and flexible. But Python also gives us another method, which is using the plus operator. Let's take a look at an example. Feel free to pause the video here and copy this code into your own editor. Once you've got it typed out, run it and watch what happens. So what's going on? We've got two variables, first name and last name. We're using the plus operator to join them together, along with a space that is within the double colons, to create a new string called full name. That gives us the name John Doe. Then, we use print to display a greeting. We're combining hello with full name, and adding an exclamation mark at the end. Python joins all these pieces together and prints, hello, John Doe. This technique is called concatenation, and it's great when you want to build messages from smaller parts. Just remember, when you're using the plus operator, you need to add spaces manually. Otherwise, your words might get squished together. So go ahead, try it out, experiment with different names or phrases, and see how you can build dynamic messages using string concatenation. Let's look at how to measure the length of a string in Python, using a built-in function called len. Len stands for length, and it tells you exactly how many characters are in a string. This includes letters, numbers, symbols, and yes, even spaces. Let's look at a quick example. Go ahead and pause the video if you need to, and copy this code into your editor. So what's happening here? We've created a variable called name and assigned it the string, John Doe. When we run len with the variable name inside its parenthesis, Python counts every single character, that's 4 letters in John, 1 space. And 3 letters in Doe. Altogether, that's 8 characters, so the output is 8. This is super useful when you're working with user input, validating passwords, or formatting text for display. It helps you understand how much data you're working with and lets you make decisions based on string size. So try it out, change the string, run the code again, and see how the length updates. It's a simple tool, but one you use all the time. Alright, now let's talk about how to access specific parts of a string in Python, using something called indexing and slicing. This is a super useful skill, especially when you want to grab just a piece of text, like someone's initials, a file extension, or a specific word from a sentence. Let's look at this example. Feel free to pause the video here and copy this code into your editor. So what's happening? We have name and in square brackets the number 0, this grabs the very first character in the string, position 0. In this case, that's J. Name -1 uses a negative index, which means Python starts counting from the end. So -1 gives us the last character, E. And name with 5:8 in the square brackets is an example of slicing. It tells Python to grab the characters starting at position 5 and ending just before position 8. That gives us Doe. This is incredibly handy when you want to extract or manipulate specific parts of a string. Once you get the hang of indexing and slicing, you'll find yourself using it all the time, whether you're cleaning up data, formatting output, or building something interactive. So go ahead, experiment with different positions, try slicing other strings, and see what you can pull out. It's like giving Python a magnifying glass and saying, just show me this part. Let's take a moment to talk about formatting your output in Python, because clean, readable output makes a big difference, especially when you're building menus, lists, or structured info. Python gives us special characters called escape sequences. These aren't visible when printed, but they tell Python how to format the text. / and n means new line, it moves the text to the next line. / and t means tab, it adds a horizontal space, like pressing the tab key. These are super useful when you want to organize your output. For example, here we are printing a list of programming languages. You can use both to make it look neat. Alright, let's jump into the editor and take a look. Pause the video if you need a moment to copy. Then run it and check the output. You should see, each language appears on its own line, indented with a tab. That's the power of escape sequences. They help you control how your output looks. Try changing the list or adding more items. Play around to see how you can affect the layout. When you're ready, come back, hit play and we'll keep going. Let's talk about something that sneaks into your strings more often than you'd expect. Extra spaces, also known as white space. These can show up at the beginning or end of a string, especially when you're working with user input. And if you don't clean them up, they can mess with comparisons, formatting, or even database entries. Luckily, Python gives us a few simple tools to tidy things up. There are 3 methods you'll want to know. rstrip removes whitespace from the right side. lstrip removes it from the left. And strip removes it from both sides. Let's jump into the editor and take a look. Watch how each method trims the string differently. It is important to mention. To make that change permanent, you can see you need to reassign the result back to the variable. That's where we set the variable language equal to language.strip. So now, language holds the trimmed string, and any future use of that variable will use the cleaned version. Try printing language again after this line and you'll see the difference. Let's have a look at removing prefixes. Say you're working with URLs or file paths, and you want to clean them up. Maybe remove the protocol part like HTTPS, or a folder prefix you don't need. Python makes this easy with a method called removePrefix. This method looks at the beginning of a string and, if it matches the prefix you specify, it removes it. Simple and clean. Let's jump into the editor and take a look. Pause here if you like, and type out the new bit of code I have added to the editor. Run the code and see what prints out. You should see all about python.co.uk. Here's what's happening. The original string includes the HTTPS prefix. When we call removePrefix, Python checks the start of the string and removes that part, if it matches. The result is stored in the variable we have set up called cleanURL, and when we print it, we get just the domain name. Feel free to try changing the prefix to www, and see what happens. If the prefix doesn't match exactly, Python leaves the string unchanged. This is a great tool for cleaning up input and focusing on the part of the string that really matters. Pause, experiment, and come back when you're ready. We'll keep building from here. Let's take a closer look at Python's print function. You already know it's used to display output, but did you know you can customize how that output looks? Python gives us 2 handy options, sep and end. Sep lets you choose what goes between items when printing multiple values. End lets you choose what goes at the end of the printed line. Let's jump into the editor and try them out. Have a look at the code, pause and copy if you wish. So, what is happening here? The sep parameter in print controls what appears between multiple items. By default it's a space, but you can change it to a comma, dash, or anything else. We then have the end parameter. This controls what comes after the printed line. By default it's a new line, but you can replace it with a space, punctuation, or even leave it blank to continue printing on the same line. Pause and experiment if you wish, with different endings, like a period, a dash, or no space at all. See how it changes the flow. Then come back and we can look at strings versus numbers. Before we jump into the editor, let's clear up a common beginner mistake, mixing strings and numbers in Python. The plus operator behaves differently depending on the data types involved. If both values are numbers, Python adds them. That's basic arithmetic. If both values are strings, Python joins them together. That's called concatenation. But if you mix a number and a string, Python doesn't know what to do. So it throws a type error, because it won't automatically convert types for you. Python wants you to be explicit. So if you want to combine a number and a string, you need to convert one of them manually, either turn the string into a number, or the number into a string. Alright, let's head into the editor and try this out together. Feel free to pause, copy the code, and experiment as we go. The first print statement we have is simple math. Python sees two numbers and adds them. The result is 2. In the next example, we're working with strings. Python doesn't add them, it joins them. So, 1 plus 1 becomes 11. Then we try mixing a number and a string. We have to fix it by converting the string, 1, into an integer using int function. Now Python adds them and gives us number 2. And finally, we then convert the number 1 into a string using street function. Now both values are strings, so Python joins them together and prints 11. Let's remove string conversion and create a type error, so you can see what happens. Pause and have a play about if you wish, then come back and we will look at multi-line strings and comments. Let's take a moment to talk about something that doesn't affect how your code runs, but makes a huge difference in how readable and maintainable it is. Comments and multi-line strings. Comments are notes you leave in your code. They're not executed, they're just there to explain what your code is doing. You write a comment using the hash symbol, and everything after that on the same line is ignored by Python. It's perfect for quick reminders or short explanations. Now, what if you want to write a longer note, maybe a paragraph or a block of documentation? Python doesn't have a built-in multi-line comment symbol, but there's a clever workaround: multi-line strings. You can use either triple, single, or double quotes to write a block of text that spans multiple lines. If you don't assign it to a variable or use it in your code, Python will ignore it. That makes it a great way to leave longer notes or temporary documentation. Multi-line strings are also useful when you do want to store a block of text, like a message, a paragraph, or formatted output. Python will preserve the line breaks and spacing exactly as you write it. Alright, let's jump into the editor and try out both comments and multi-line strings so you can see how they work in action. First, we'll use the hash symbol to comment out that line we used earlier to create a type error. This tells Python to ignore the line completely. It's a great way to temporarily disable code without deleting it, especially useful when you're testing or debugging. Next, we'll write a single line comment using the hash symbol to demonstrate how comments work. This is perfect for short notes, like explaining what a function does, or why a certain value was chosen. It's quick, clean, and helps make your code easier to follow. Now that we've seen a single line comment, let's move on to something longer. We'll create a multi-line comment using triple single quotes. This lets us write a block of text that spans several lines, ideal for more detailed explanations or documentation. We'll do the same using triple double quotes, just to show both styles. Python treats them the same way, so it's really up to your personal preference or your team's coding style. When we run the code, you'll notice that nothing appears in the terminal. That's because these multi-line strings aren't assigned to a variable or printed, they're simply floating in the code. Python sees them, but since they're not being used, it skips right over them. Now, let's take it one step further. We'll add a print function to each of the multi-line strings. This time, when we run the code, the text appears in the terminal. Why? Because we've told Python to actively use those strings, to treat them as output, not just ignored notes. This is a great way to see the difference between a comment and a string that's actually part of your program. Now that you know how comments work, here's a challenge: go back through the code we've written today and add comments to each section. Explain what each line does, why it's there, and what it's meant to show. That way, if you ever come back to this code later, or if someone else reads it, they'll understand exactly what's going on. Comments are like breadcrumbs for your future self. They turn your code into a story that's easy to follow, easy to debug, and easy to share. Give it a try. That's about it on strings for now. Thanks so much for watching, and we hope you found this helpful. If you did, don't forget to like, subscribe, and hit that notification bell so you don't miss future tutorials. If you'd like to grab the code we worked on today, and other resources, head over to the website. And as always, keep experimenting, keep learning, and keep making your code speak clearly. Until next time, happy coding.